This is an extremely big number. This number is so big that, I think if you try to write it down in digits, you would die if you actually started the first Planck time, which is the smallest amount of time that you were born, to the time you died. So it's a pretty big number. It's a very big number. The number, although it's very big, I didn't just, flunk it out of the air. It has a purpose. I think you already saw it by this time. The purpose of the number is how many combinations of atoms can you arrange in the quantum state? The quantum state is a universe to be stable. Every combination has to be stable for matter. No, but that don't mean you just have to first I'll explain what a quantum state is. A quantum state is a range of atoms in one biological thing in the universe. If there's a video, if the universe was a googolplex meters made by Numberphile, and it kind of explains quantum states and it explains the states, the quantum states, and how big it is, I think. Anyway, it explains that if you lived in a universe with a googolplex meters, you would actually see repetitions of yourself if you went far enough, because each quantum state is on a range of atoms. So let's expand to the size of a universe. Now, the combinations of atoms can be everywhere. So there are lots of combinations. There are trillions, I shouldn't say trillions, much more than that, of combinations of the states, to be a universe. But the number is not infinite. I'll show you the number. 10 to the power of 10 to the power of 200. That is bigger than the googolplex. You know what the googolplex is, right? It's 10 to the power of 10 to the power of, 100. And if that is incorrect, and you heard my question correctly, be sure to comment and tell me what the real number is. Don't waste your time writing it on digits, because this number is humongo. So I think you could actually correct it if you heard the question clearly. Now, the reason why the number isn't infinite is because in that would be kind of called like a multiverse. Multiverse is a group of universes, and the universes are infinite, and so you kind of have to each universe has to be stable for matter. So if there's a universe with crazy laws of physics and you can have matter in it, that wouldn't be considered a combination in this equation. So if I think you heard a question right, and you might be able to correct it, or for a coincidence, that number can actually be right. Anyway, this number is tiny compared to some of the really big numbers, like Graham's number or googolplex, which is one with the googolplex zeros. Anyway, this number is still kind of big, but at least it has a purpose. And, That's a kind of big number. So anyway, I think there are certain amounts of quantum states for there to actually, I think there are limited of quantum states which can actually have matter. So it could be even bigger than that or less or exactly the same, but it's definitely not infinite. So the number is pretty big, and if you saw that video made by Numberphile explaining Google and Googleplex, go check that video out and, watch that video. Every quantum state needs matter for it to be able to join this equation and add those all up, all those combinations, and that would make the true number of, this. Maybe it could be bigger than Graham's number. Who knows? But then again, Graham's number is humongo. Anyway, thanks for watching this video.